Okay, so we're working on, oops, there you go, solving inequalities. Essentially what this question is telling us is we have some kind of function here, and the function we want to discover when the x values are less than 0. So 0 being on this side of the equation. What we'll do is we're going to take a quick look at it and see if we can figure out what the degree of this function is. Okay, so our first set of brackets has a degree of 2, the second one has a 3, and technically the third one actually has a degree of 1. So if we actually add those all together, okay, we can get 6. In other words, what this is some function to the power of 6, and it may have a bunch of it after it. Why that's important is it gives us the general idea of how this function is going to work. Recall that your parabolas, or anything that's even, has roughly this shape to it. It comes down and then curves back up, right? Quartic could be something like that. And then this 6, I can't even remember what it's called, could be like even something like that. But that's the general shape to it. And it might cross through the roots here on x. And in fact, it most certainly does, looking at what we have. But we want to know that general shape. That's really important to how we're going to solve this inequality. The next thing we can do is when we look at the sets of brackets, we're going to find roots. And these are essentially when x is equal to 0. So we can find those really quickly. And remember, this is an inequality here, so it's less than 0. So we can technically set up like this. X minus 1 is less than 0, which would mean x is less than positive 1 as one of our options. Another one could be x plus 4. And is rooted. That root actually becomes really important. We'll talk about why in a second. Another one could be here, x plus 4 is less than 0, x is less than negative 4. And then finally, we have x minus 2 is less than 0, we have x is less than positive 2. Okay, so what that's telling us is we got to figure out points along here when x is going to be below the x-axis. Okay, when was this function be below the x-axis? Well, we know that it actually also has a positive coefficient to it. If we look at all the values of x's, when we multiply them all across, we're going to end up with a positive value. So in other words, it has this general shape and it's not actually going downwards. Had it been the coefficient of the leading degree had been negative, we would have been going downwards like that. What this also tells us is these are pretty much roots. These are roots along the way. So one of them is here at positive 1. Another one, is that right? Positive 1? Yep. Another one's at positive 2. And another one is at negative 4. Because we know the general idea of this function, we know it's going to be coming from this top left corner up here and heading downwards. What we want to do is look at the degrees of our roots. So this degree here of 2, it's an even degree. What that's going to mean is it's actually going to not cross through at 1 because the degree is 2, but it's actually just going to touch down there, okay? So I'm going to redraw this graph a little so that we can help us make a little more sense of it. So we have one point, which is at negative 4. Another one's at positive 1. Another one's at positive 2. We know the graph's going to come down. When it gets to 1, it is going to touch on this, okay? So it does not cross. So I'm going to say does not cross. Use that Gandalf there, meme there. And then these two are odd. Odd means it's going to cross through our axis, okay? So with that being said, we can order these. If we take a look and we go greatest to least, we have, least to greatest. We have a nice little number line here. It'll help us make sense of the order we're going to do things in. But negative 4 is way back here. Then we have positive 1, and we have positive 2. At negative 4, I know I'm going to cross. And at positive 2, I know I'm going to cross. I put x's there for crossing over, and all that means is it's going to cross through. But at 1, it's just going to touch. And then it's going to go around the other way, go back the way it came. So if I'm doing a rough sketch, which is what I'm going to do on this graph down here, I'm starting in this top corner, and technically this is continuous. It goes on forever. But it's going to come down and cross, and then it's eventually going to come back up. I don't know exactly when. It's going to touch 1, head back down, and then come back up again. It crossed again at positive 2, which is exactly what we said. And if we take a look at this general shape, the general shape is kind of that parabola. It's that U form, which is great. What we've now discovered, we can generally look at this graph. When is it less than x? When is this graph less than x? Well, from -4 to 1, it is less than x. So we could say x, you can make the argument that x is between -4, and we're going to say completely less than 1. And the reason we're going to say completely less than 1 and not less than and equal than 1 is because it actually touches at 1, and at that point, that value is equal to 0. And if you look at the original inequality, it only states for less than 0. Okay? The other part we can say is you can also say x is between 1 and 2. And 2. So it's going to be greater than 1, but also less than the value of 2. I think your teacher has written it more in like a set notation. I think they do something like this, as these are the extreme values, and they put this as the union, where x is an element of the union of these two things. If you take data management, that union concept makes a lot more sense. But if you're used to just writing out maybe domain and range and set notation, this version here might make a little more sense to you in that question.